Hi everyone. I decided to make a little bit of an update here on the Triple M Super Build and show you that there is progress. It just takes a little bit of more time. There's a lot of things to think about here in this build. And right now I have the ends for the glide system epoxied on the two ends here of this coil, and both coils are made the same way. And the way I made it is I used 1-inch thick MDF, and here you could see possibly a seam here in the center, and that's the 1-inch dimension there, and it's also cut 1 inch wide. And I made 4 identical pieces like this here, and there's the other 2. Well, and then there's another 4 on that side as well, obviously. And then there's a piece here in the center which creates the distance between all this. And this is all glued with just carpenter's glue, this stuff here. But then there's a gap left here on each side, so that basically I sand the surface of the epoxy here, because there's an epoxy finish on the coil, and you can see that there on the edge. That's sanded there. And the reason why you sand fresh epoxy is new epoxy won't stick to fresh epoxy, because you can feel it's very slippery and kind of nearly oily. So you have to make sure to always sand new epoxy if you're going to adhere another coat of epoxy on it. So basically epoxied all that end there, and then the tip as well with epoxy, and then just slid this block over the coil there. And if we look inside there, you'll see there's epoxy that just bled out a little bit, and that's a really good sign that you've got epoxy everywhere in there. And there you see my 2 leads coming out where I'll be attaching the wires to as well. And there's the bottom. Bottom's the same thing, and epoxy has come out of that as well. So both ends are the same thing, same configuration. And here I have the bushings. There are 4 bushings like this, and attached to a wire, and I'll show you why I have that there in just a second. Here is the bushings that will be then epoxied here as well on the tips of the coil and of this system here. And what it is basically a 1/2-inch rod, okay, 1/2-inch steel rod here. Basically the bushing will, I'm trying to do this here holding the camera at the same time here, the bushing just slides over this rod here, and that bushing will actually get epoxied there as well, and then the other one there as well. So both ends it's the same thing. And then there's oil, fine oil put on this, and then the coil can ride and be very precise its movement, and we won't have any movement whatsoever from this dimension, which is really important to not drop that rod, to not have a twist going this way. So that's the whole idea why I have 2 of these here, to prevent swinging this from this dimension here. And what I'm going to do now is use my scale here. We'll turn this on, and we shall weigh this. I haven't even weighed this. So right now I'm on the kilogram scale there. And so basically this will be the final weight of this whole thing here. Oops, this scale here has a problem. I gotta zero that again. Okay, we gotta do this in one time to get the correct reading. Okay, so we're at 2.2 kilograms, 2.325 kilogram is the total weight of this. So for pounds, just multiply that by 2.2, and that's the approximate amount of pounds. Alright, so that is the coil, and then the coil will now get inserted inside the sandwiching here of the two steel plates, and as you can see now, this coil is actually in there, which is on the other side here. And on the center here I have 2-inch block by 1-inch high N52 magnets, and there are 4 there across and another 4 on the bottom. So here we have a north on this side, north there, so we have 2 opposing norths, and that was quite a struggle actually to put those magnets together, because I don't know if you ever worked with magnets in opposition, but eventually what's happened here is I didn't really think that this whole plate would get totally saturated, and it did. And my last magnets, the only way I could actually stick them onto the 1/2-inch plate was to put the outside 1/4-inch plate so that the magnet would actually hold in position, and then I had to use a really large vise to squeeze it all together and glue them. So if you look closely there, well, you might not tell, but there's super glue that's been, you know, put to the edges around all these magnets, and it's kind of holding together with super glue, and magnetically coupled to this top and this bottom. And then this bottom is epoxied to this big 1-inch MDF piece here. And here, if you look, you obviously see there's a tape there, and that's masking tape. And what I have done is I have wrapped 3 layers of the masking tape on the bottom, and actually a 4th layer on the top here. And that's so that when I slide the coil on here, I just put the coil over top of this tape, and that's my air gap, so that the coil is centered. I just want it up a little higher, and then once both the coils are there, then I use my this rod here. Well, it's going to want to get magnetically coupled, and obviously it will get epoxied on here. And then I have little supports here that I've made. Here they are, and these are to hold the, so I made that with 1/4-inch plate, and I bent it myself just by making a groove in there and bending it in a vise. And there you go, makes a nice bend. And these will be here, and they're going to be drilled with the 1/2-inch hole to hold this this rod here, and at the correct position. Once all this is all in correct position, then basically wherever the right alignment here, it has to be very precise, then that's when I epoxy the bushings. So that's done at the very last thing, and just to make sure everything aligns and is perfectly square and straight and all that. So there's a lot of precision work here, because actually my air gap is a bit smaller than I actually thought it was going to be. So it's pretty tight, but there should be no problem once I have all these positioned correctly, and you know, all the holes made. And I'm working with a micrometer to get the heights exactly the right height, and then the dimension as well, equal, you know, out from where the center plate is. So all that needs to be taken care of. So this coil here gets positioned onto this tape, like I said, and then the next thing is to put the 1-inch magnets on the end here. So I have 8 of them going up here, and then 8 of them here. Now I'm a bit hesitant with that, because already with my big 2-inch Neos here, this core is saturated. So, oops, as you can tell, it's very serious magnetic pull. I can't even get that off there with one hand. So I don't know if I'm going to be able to even put those 1-inch cubes in there, because there might be a point where the magnets will just fly off. because there'll be hardly anything holding it, because everything's in opposition. So obviously we have a north here, and the center plate is north, and here I have to also put the north, and it'll magnetically connect to the top here because it doesn't have that huge of an opposing force, but here it's like double, so it's very, very strong in the center. So hopefully it's going to work. If not, this will be a failure, and I will have to actually make this run here, which is a 2-inch movement. So it has the ability to move 1 inch this way. The coil is 1 inch wide, so 1 inch this way, 1 inch that way, so basically 2 inches across. And actually, now that I see how strong all this is becoming for the magnetic flux, I should have actually made it 4 inches. And I even had this steel plate. I had to buy a foot of it, and I cut it down to 8 inches basically, so that I could have that 2 inches of travel. And I should have just left it like that and have actually 4 inches of travel. That would have given me more steel for the magnetic flux to go into, and I don't think I'd have this much of a problem. So hopefully I can put that together. If not, if it gets too dangerous and I can't hold in those magnets, I think it'll be too much of a dangerous thing. The magnets flying off is not an interesting thing to experience. So that is possible downfall that's going to happen, and I can't get this thing up. So that's what the update is, and also here's my inductance meter, and I've got that hooked up to one of the strands of the coil here. Remember that this is a bifowler coil, and that's only to one strand. And I actually, with the coil now in there with the steel plates and just those center magnets, the inductance actually has dropped down compared to just the air coil. So that's kind of interesting. I haven't seen that before. And we have 1786 microhenry as far as inductance of one coil is. And when I connect the two coils in series, the bifowler series, my meter somehow goes kind of like strange and clicks on and off, and if I do even get a reading, it just jumps to something like 90 or 60 millihenries, so which I don't think is quite possible to jump to there. So I'm having a bit of problems getting an exact reading on that, but I think what it looks like so far, this might be the correct inductance at this time. So I thought it was actually in millihenries, but it's actually in microhenries. So this is actually only 1.78 millihenries, so below 2 millihenries. So that's the inductance value, and I think that's about it for now. So as you could see, this is all the pieces of the puzzle, and that's the other rod there. So the two rods are ready. I have my 4 supports, and that's what I'm doing tomorrow, is just going to be drilling these supports to make the hole for the precision hole for the rods, so they're in position. So that's about it for now, and thanks for watching. Bye now.